Out of all the tests that determine the convergence of an infinite series or divergence of an infinite series, most students' probably favorite test is the p-series test. It's probably the easiest test to use. So here's what it says. It says if you have an infinite series of this particular form where you have 1 over n to some power, which happens a lot in these series, then it converges if the power is strictly bigger than 1, and it diverges if it's less than or equal to 1. Now, if you think about why that's the case, well, I think in a previous video we looked at this example where we compared the sum of 1 over n versus the sum of 1 over n squared. And we discussed the fact that these terms are both going to 0 as n goes from 1 to infinity. So the terms that you're adding are getting smaller, which would tend to indicate that it could converge or has a chance of converging at least, but the speed at which it goes to 0 is very important. And I think if you do a little analysis on this, it's pretty clear that 1 over n squared gets to 0 or approaches 0 much faster than just 1 over n, even if you just do a term-by-term comparison. 1, a half, a third, a fourth, a fifth, versus 1, a fourth, a ninth, a 16th, a 25th. These terms get much smaller, much faster. So it seems to indicate that the higher the power, the more likely it is to converge. Now, it is a very fine line. It's very much on the fence post. And the fine line, the line in the sand, is at 1. If your power is even just a tiny fraction of a hair larger than 1, it'll converge. But if the power is equal to 1, it'll diverge. So this diverges, but just barely. If this had been 1 over n to the 1.1, it would have converged. So the power of 1 is the very fine line as far as p-series are concerned. So let's look at a few easy examples just to begin with. These are quite simple. This series here, if you were given this on a test and asked, does this converge? We would simply say yes by p-series. Why? You look at the power is 3. It's just a direct relationship to that test. This one here, it doesn't look like it has a power initially, but obviously we realize that the square root of n, that's the same as saying 1 over n to the 1/2 power. So a square root can be related to a 1/2 power. So this is no, it diverges here. And then 1 over n to the 1.0001, that'll be yes, it converges. So the first and the third series converge, and the middle one diverges just by a direct application of the p-series test. Now you do have to look at a more realistic example. Those were, to be quite honest, very easy. This is more typical of what you would expect to see on a test, maybe even one a little tougher than this one. But you look at this and they say, does this infinite series converge? Well, you look at it and you say, well, that doesn't really look like a p-series. Well, some of these you have to work on first. You have to change the way they look, algebraically simplify them, etc., etc. Like for this one, 10's a constant. It could be pulled out of the series. It's a common factor of every term in the sum. So you could pull that out, or leave it in for that matter, but we'll just pull it out. Sum n equals 1 to infinity of 1 over, and then if you look at these terms, you have n to the first times n to the 1/2. A property we should all know about terms that have a common base but different exponents. You can add the exponents. So this would be 1 over n to the 3/2. And we say, oh, well, this is quite simply a p-series, and this will converge by the p-series test. P-series test, since the power is strictly greater than 1. Now, one thing you have to be real careful about, I wanted to make sure I put an example like this in here. The p-series test will bite you if you're not careful. Students love the p-series test because it's so simple, and it is, but you can only use it if it looks exactly like a p-series. The series must look exactly like a p-series in order to use the p-series test. So if you looked at this one, a student would look at this and say, oh, well, you roughly have 1 over n to the 4th. So I think this converges. And I agree. I think it converges as well. But technically, you cannot just quote the p-series test because this plus 5 makes it not fit the technical model of 1 over n to the p. Um, Now, between me and you, this series is going to converge. You just have to be very careful on how you say this. If you want to watch the video on the comparison test, this will handle this situation where the comparison test, you can probably tell just by the name, you can compare a series that looks almost like a p-series and make some sort of relationship there to where if 1 over n to the fourth converges, then 1 over n to the fourth plus 5, which the plus 5 really doesn't do a lot in the big scheme of things, then it will converge. But you have to use multiple tests for an example like this.